All right, welcome to day 4. We're going to look now at understanding no solutions and infinite solutions when solving these. So let's start with a simple case where you have two lines have a solution at 5, 8. So what's going to end up happening here, we'll do the graph second, but you're going to do, the work, dot, 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 and you're going to get x equals 5 and y equals 8. So they're going to intersect at 1, 2, 3, 4, 5, 8. And those lines could be anything. It could be something like this and this. Um, It can be something, vertical and horizontal. It can be something, vertical that way and this. So as long as they intersect here at 5, 8, that's the solution at 5, 8. Let's go down here. Where do they have no solution? So first thing, understand, these are parallel lines. Okay, so if you notice, they don't intersect, so they're not going to have a solution. If you're doing work and you get something like 0 equals -5, okay, something like that, put a couple question marks. So if you're doing the work, if you can't recognize that the lines are parallel when you start the problem, you might, do some work. And if you get down where every variable x and y cancels and you're left with some gibberish, like 0 equals -5 or something to that effect, that's what will happen when you have no solution. So again, you won't get x equals y equals, you just get some kind of gibberish at the end. That's what we mean by no solution. Or if you graph it and lines are parallel, that's no solution. How do we get more than one solution? That's two lines, or lying on top of each other. So it really just looks like one line. And what happens is when you do the work, you'll see something like this happens where you get 5 equals 5. Right? Again, we don't have x equals or y equals. We have this. Well, we know 5 equals 5. It, of course, is 5 equals 5. So this ends up being a more than one solution when you get something like this. When you get gibberish, it's no solution. And when you get an answer, that's the solution we're looking for. So if you take a look at this problem, it's called the astronaut problem. Take a moment just to pause the video, read through the problem, and then we'll move forward. So hopefully you have a gist of the problem. You've taken the time to read it. These are the two equations that come up from the problem. And what I want you to notice is this. Let's double the bottom equation. That way you can match it up and maybe do elimination. So we have our 30x plus 40y equals 600 up top. On the bottom, we have 30x plus 40y equals 400 on the bottom. And we're going to try to solve with elimination. So what you'll notice is that when we subtract, right, the signs are the same with 30. We'll subtract, but notice they're the same and they're the same. This is generally one of those, when you see that the top and the bottom are the same in an elimination problem, what you end up with is the 0 here. And in case 0 equals 200. Now this is a gibberish situation. So will they be able to do the diet? The answer is no. There's no solution to this that will actually work. And you're going to end up with two lines that are parallel. So here's just a practical example. Good luck. Let me know what questions you have.